Okay, here we go. This is the lesson from 6.3. If you take a look. 6.3 collision theory. So our learning goals for today are to describe the collision theory and how it relates to rates of reaction. You should be able to draw potential energy diagrams that include activation energy and transition states, and explain how catalysts impact activation energy. And the last one is explain how concentration and surface area impact the rate of a reaction. So just to recall, the rate of reaction is measured by measuring the change in concentration over a period of time. Okay, what is collision theory? So it is a theory used to explain chemical reactions in terms of effective collisions. So in order for a collision to be effective, particles must have the right orientation or the proper orientation and enough kinetic energy to break and reform the bonds. So right here, it shows you in the first example here, it shows you that these particles A and B are in the proper orientation to collide, and a reaction happens, they form their products. Here though, they are facing the wrong way, like they're in the incorrect orientation, and therefore the reaction does not happen. Okay, right here, you must have the second condition for an effective reaction to happen is the particles must have enough kinetic energy to break and reform bonds called the activation energy, EA. So this is the minimum energy that reactant molecules must have for a reaction to be successful. So as you can see here on the curve, here are the reactants. And this amount of energy here called EA is the minimum energy required to reach the product. So if they don't have this minimum energy, it's kind of like an obstacle they have to overcome, then the reaction will not happen. Okay, so activation energy is the minimum collision energy required for an effective collision. It's dependent on the kinetic energy of the particles. So an analogy to this is if the ball does not have enough kinetic energy to make it over the hill, the trip will not happen, as shown in the graph on the right here. Okay, so the ball must overcome this energy in order to do the trip down the hill. So that's an analogy to understand what activation energy means. Okay, so again, particles, they must have enough kinetic energy to break and reform bonds called the activation energy or the threshold energy in the left graphic below. So on the left here, it's showing you a graph